Hey guys, welcome back to the shop. So today I'm going to go ahead and attempt to get our stylus replaced on our Renishaw probe. Recent video I showed where I actually broke the ruby tip here. I came down in Z unexpectedly. I thought I was moving over an X, and I came down in Z whenever I rotated the hand wheel, and it came down just enough that it shattered the ruby there. I don't believe I did any kind of damage to the probe unit itself, the sending unit. I think if it would have went down any further, it probably would have broke more of that ruby off and maybe even shattered the ceramic there. So this part is what is designed to break in the event that you do hit it or something, so that it doesn't mess up the rest of the sending unit here. So I think the tool itself is fine. We just got to replace the stylus on there. So I did order 2 from Renishaw, so we'll have a backup. So mine's the model A5000-3709 for the OMP40 model. And these cost $97 a piece, plus shipping. So, you know, that was a good $200 plus order right there, or $200 mistake that I made. But it makes me feel a little bit better. I shared this on Instagram and Facebook, and you know, had a lot of folks leave comments and say, hey, this is a very common thing. We all do it. Even the best CNC machinist out there eventually breaks a probe or have broken a probe. And it's just another learning lesson, and that's how I look at it, is that every time you make a mistake, you use that as a learning lesson. And it was for me, because I was moving a little too quickly. I reached up with my right hand and I thought I tapped X on the controller, and I didn't actually push X. It stayed in Z. So when I reached over the hand wheel and cranked it, I came down. And so I was just moving a little bit too quickly. I was a little too sure of myself there, which is where I have to kind of put myself in check and make sure that I continue to do these things slowly and methodical to prevent any kind of damage. I was so proud that I've gone as long as I have without breaking the probe here, but it happens, and it happened to me. A lot of guys say that's a rite of passage when you're learning CNC work, is you know, breaking a Renishaw probe. So anyway, expensive mistake, and hopefully it won't happen again, but if it happens again, we got another backup there, stylus. All right, so I got the instructions here from Milltronics on setting up the Renishaw spindle probe on their controller. They went ahead and explained to me how to replace this. So this is just simply unscrews, and then you tighten the other one back up. We'll do that. And then these instructions here go over the calibration that we need to do to find XY center, and then the Z0 as well. So the instructions call out for using some kind of ring gauge. This is one that I have right here. We'll be able to get that clamped down to the table, find the center of that to do our calibrations. And then for Z, the instructions say you put a piece of stock in the vise or in the machine, mill the top of it with a tool that's already preset, and then we bring the probe in there and touch off on our Z to calibrate the tool length there. So hopefully we can get all that right. So let's go ahead and get our stylus replaced. All right. Okay, step number 1, we need to remove this. So use a pick or some kind of little Allen wrench and stick it through the hole. Okay, there we go. And just simply unscrew it. I think that's going to be the easiest part of the whole job. So let's get our new stylus out and try to be very careful not to drop this sucker. All right, get it screwed in. And then snug it up. It wasn't real tight, so I don't think we need to over torque this thing. It should be good right there. All right, there's that. So now we need to install it in the machine and go ahead and indicate the ball, the ruby here. We need to indicate that and get it running as close to 0 as we can. Next up, let's get it loaded up. And now we got to get the ruby indicated. All right, we're going to get a Noga set up here with we got our Starrett test indicator set up. right in the middle of that ruby. Light seems to be blowing out the dial face there on camera, so I'm going to just turn that off for now because I can see it just fine. All right, I think that'll work there. Let me just use the hand wheel here to see if we can get it on 0. All right, that's pretty close right there. Wow, that is, I didn't expect it to be that far off, but apparently that's why you got to indicate this thing in. All right, so it's going to work like a 4-jaw chuck. On the body here, you've got 4 set screws that you have to adjust to compensate for the run out on the Stylus there. So we'll get our Allen wrench and see if we can start getting it indicated. All right, here we go. I know how to indicate a 4-jaw chuck. Let's see if I can, I just want to make sure that it's not, it shouldn't be loose. That's what I was looking at right there. All right, and you got 2 more set screws. I don't know which way I got to go yet, so we're just going to roll with it and see if I can get lucky. And okay, I think I got it. So that's going to be your low. So I'm loosening the low. And then tightening the high side. That's high. That's low. So let's crack this one. All right, I think we got it going our way. Got it pretty close there. I'm going to go ahead and adjust that indicator again and try to get a little closer to 0. I'm just using the table movement here to try to get it lined up. Looks like 4/10. So we'll start with our high and see if we can get it pushed over any more. Nope, I'm gonna have to crack it loose. And the instructions that they gave me is 0.5 thousandths or less. I think on the Renishaw website it said 1/10. So when I cracked that one loose, it went a little too far. So I'm going to go back in with it. All right, so no movement whatsoever. And you know I don't trust that, so we're going to back it up and go back into our preload. All right, so I'm really not seeing any movement. That little bit of movement there I think was just the indicator trying to get settled in on where it was at. Less than 1/10 of movement. I think we got that guy indicated already right there. I need to make sure that all of our set screws are tight, that I didn't loosen one and not tighten it back up. So we're going to check those. I'd say less than 1/10 TIR right there. I think that's going to work. All right, next step it says is to remove the large key from the spindle. If the machine has an inline spindle, remove the wide key from the spindle. Calibration will require the tool to be reversed in the spindle, and the wide key will prevent this. So it should be this one here. That's going to be tricky. Maybe I'll just go get my little impact gun and see if I can crack it loose with that. Let's see if we can get it out with this guy. Yeah, much easier. Okay, I've got our gauge ring here clamped down to the table with a couple strap clamps, and the dimension of the ring, what it was measured and calibrated to, is etched on there. It's just really hard to see. So that's the size of the hole. Wrote it down so that we can simply put this in our machine. So we'll bring our probe down here and use this to get our XY calibrated. Okay, so it's showing that tool 5 is active, and we want the Renishaw probe, which is tool 99. So we're going to do a tool change to tool 99. Bring that back up to 100. We'll put tool 5 away, which I actually took out of there. All right, insert tool 99 and then push tool reset. All right, probe installed. It said write a code G65P9301, and then go ahead and run that. So we're going to hit run, cycle start, and then hand wheel mode. So it's telling me to go ahead and go over to the center of the ring gauge, press escape to abort, or enter to continue. So we'll go ahead and do that next. Let's go ahead and eyeball the middle of it the best we can. It's looking pretty good right about there. Okay, we should be good to start our calibration process. I'm concerned about these maybe being in the way, but I think everything's far back enough that it's not going to hit the body. I'm going to keep the rapid control here down low, down on 20, and just watch that as it goes over, and we'll stop it if it looks like it's going to get too close. Okay, so we've got it in the center. We want to press enter and put the exact diameter of the ring gauge. I've got it written there, 2.0476. 2.0476. That should be good. And then I've got my instructions right here. The probe will touch 4 positions around the ring, and then it's going to prompt us to rotate it 180 degrees in the spindle. So let's go ahead and hit enter. All right, I got my hand on the feed knob up here. Should be clearing just fine. Okay, program stop and counter. Rotate the probe 180 degrees by removing it in the spindle. We've already removed the key. All right, and then we'll hit cycle start to continue once we do that. All right, prober's rotated. Let's go ahead and hit cycle start. Is it going to let me hand wheel it? Nope, it's coming down. I'm assuming it's going to come down to the same position that we started in. Bring it down nice and gentle, make sure it doesn't fly over somewhere. Okay, same Z position. And back on the rapid switch. All right, back up. Program stop and counter, rotate the probe 180 degrees, and then hit cycle start to continue. So we'll go ahead and flip it 180. All right, just installed the tool 180 degrees. Cycle start. So I believe it's going to come down and just do the same thing again. And it's going to average out all of the contact points that it's measuring to find the average of the center. Back down to 20%. All right, it's going to do it again. Sped it up just a little bit. We're up to 40% rapid now. Looks like it's measuring it quite a few times. Oh, now we're doing the 30-degree points. All right, so we're at a program stop. Caution, either remove the probe or make sure the probe is in the correct orientation for tool changes. Press cycle start to continue. Either remove the probe or make sure the probe is in the correct orientation. Well, it should be in the correct orientation. All right, we're going to drop this down to 10 and hit cycle start. All right, I think that was it for our XY. I'm going to go over these instructions again for the calibration for XY and be sure that that's finished up. All right, yeah, that was the end for the XY calibration. So I've got the instructions set up for calibrating Z-axis now. This is where we need to actually install a tool that's already been measured on our tool setter right there. So we'll probably just go ahead and grab tool number 1, and we just need to bring it down. We'll just manually move it and just cut a flat spot on top of this piece of aluminum there. That's what they said. Put a piece of stock in the machine and just cut it with a known tool length, and then that's the surface that we'll use to probe Z. I'm going to go ahead and put our key back in. And we should be done with that part of the calibration. Give it a bump with our little impact gun here. All right, so let's just use our tool number 1. It looks like a 1/2 inch end mill. Tool 1, M6, run it. It should prompt me to, yep, okay, tool change, insert tool number 0, empty the spindle, hit tool reset because we had our probe in there. So tool reset. There we go. Now I'll just walk it down here. I'm just going to use the hand control and just mill a little flat spot there on the top of that aluminum block. All right, I'm going to use our hand pendant for this right here. And I got our speed set to 1,000 RPM. We'll go ahead and turn spindle on. Walk it down and we get it touched off here. Z. There we go. All right, let's go back in X. Let's slow it down. That should be all we need. I'm going to go back across there. All right, spindle stop. Okay, that should be a good flat spot for our probe. All right, so we haven't raised it up in Z. We've just cut it and just left it right where it was at. We're still in our hand wheel mode, got the pendant turned off. We're in Z, and then what we want to hit is the F7 G54Z. G54Z. All right, so that should be good. We're going to go ahead and Z it now. And that should be 0, enter. Okay, we got our Z set to 0. Now we can go ahead and install our probe again and continue down our list. So we're going to want tool 99, M6 tool change. All right, insert tool 99 and tool reset. Renishaw installed and tool reset. Clear the work area per cycle start. Okay. Now when you're gonna, okay, we're already in MDI, so we need to type in this program G65 P9801 Z0 tool number, where T is the tool number of the probe, so that's going to be tool 99. Run the program. Probe will touch the surface several times and write a tool length offset into the tool number indicated. That should be it. So let's go ahead and write our program. So we want G65, and then we're going to do a P. Let's see, I don't think it matters, but we'll just go ahead and hit space. And then P9801, 9801, and then we'll do a space, and it's Z0 space, and then tool, so T99, and run. So let me make sure. Well, the first thing we need to do is go ahead and move it over to the calibration surface. I didn't think to do that, so let me exit out of this. I'll have to just redo that. We're going to go back to hand wheel mode right here. All right, let me get it over. And then we're going to bring it down to about 2 to 300 thousandths above the part. All right, so somewhere right in that neighborhood is fine. Now we can go ahead and write our program. I got to do all that again. Let me get this written. I'll bring it back. Okay, we got our program written. We're going to go ahead and write. I brought it down to about 40% rapid. Cycle start. Program stop and counter. Probe may be out of view. Press cycle start to continue. It should be right there. There's the receiver. There it goes. Got it that time. Well, it only did it once. I'm gonna go back and make sure that I have this done correctly, because it said that probe will touch surface several times and write a tool length offset into the tool number indicated. So let me go ahead and double check myself that we've got that done. I think we're ready to roll though. I've done the Z calibration 3 times now, so I feel good that we're there. I've just gone in there to MDI and rewrote this line of code here, this program, and it did the normal like single surface touch off, where it touches it and it comes back down and touches it again, like it verifies it and comes up and it goes back to the MDI screen. So I believe our Renishaw probe is now calibrated. So I'm going to go ahead and take this tool out. So this is where you have to be really careful when you're moving this thing. This is where I actually broke the ruby before, because I reached up here, it was in Z, and I thought that I pushed X, but it wasn't actually selected. And then I was looking down here, reaching up here with my right hand, and I turned that hand wheel and it came down just enough to break that ruby. So this is where I have to really be careful that I'm doing things correctly. I like to just crank it a couple times and see which way it's going to make sure that I'm rotating it the right way. So I'm gonna go ahead and I'm gonna do like a tool 0 tool change so that it turns off the probe now. I like to just go ahead and take it out, so we're gonna remove it now because the probe is still on. So I need to go ahead and do a tool change, which we'll do now. Come up to an MDI. Let's just do tool 0, M6. So that should cancel out that program. Yep, tool change, insert tool 0. We're going to do a tool reset and hit cycle start. And there we go. And now our probe is turned off. I think this guy is ready to go. I really hope it is. So I guess I need to just go ahead and do like a test and center up a work location and make a cut with a tool and make sure that we're in the right position. But other than that, I think we're ready to roll. All right, I feel good about our new calibration for the Renishaw probe. I went ahead and put the tool number 1 back in there and brought it down to our Z0 after I located. What I did was I touched off Z one more time. I made this G54 Z0 that brought tool 1 back out, brought it down to absolute 0 there, and run the tool back across there. And this is lined up just as smooth as it could be. So I feel good about that, and I'll know more once we get into my next little job where I'm using the Renishaw probe. So I think this is all finished up. So the last thing to do is go ahead and put this guy away. So I keep it down here. I've got this tooling cabinet in that pocket right there. I usually keep it right there. Those are my spare holders. I usually just keep it right there against the side. And then up here in this drawer, I've got my spare stylus there. And then these are the batteries that I keep that go in the Renishaw probe and the Renishaw tool setter there. So I have backup batteries, and now we have one backup stylus there for the probe. So that job is finished up, and I just wanted to kind of share that with you guys. You know, this was that was a completely new sequence for me. First time breaking a Renishaw probe, and I'm thankful that I didn't do any more damage than I did with, you know, just the stylus. We didn't damage the actual sending unit or anything like that. But I just thought I would show you my learning curve of going through this this proper sequence of recalibrating it, you know, changing the stylus and recalibrating it and all that stuff. So maybe that's going to help somebody else out there, or maybe you guys that are running the Milltronics, you're going to have to go through the same sequence there as well at some point. But anyway, I just wanted to share that as part of this CNC journey, is sharing what I'm getting into, my experiences, my learning, my failures, all that stuff. I'm trying to share that and document here on the channel, and this was just another aspect of that. So hope you guys enjoyed watching and following along, and I've got plenty more to share with you. So hopefully we'll see you on the next video.